I'm on a team with Behrooz Kamali, Jose Cadena, and Devi Mishra, and we are presenting our progress on our project involving classification and visualization of crime data. So this is a web application that we've built. It's pulling some crime records from the Washington, D.C. dataset that was supplied to us. And what we're doing is we're just simply placing it on a map with each point showing which category the crime is from. So this view allows us to filter on various things, and it allows us to also generate a heat map so we can see which areas of Washington, D.C. and the surrounding areas are high in crime, and we can zoom in on this map and see in finer detail what these high crime areas are. Alright, so backing out to the individual points for each crime category, we can set a filter for what date ranges we want to see. So if we zoom in here a bit, this is limited to 10,000 data points. Grabbing all 126,000 was a bit much. So we can filter from 2003 to 2009, which is should include random sampling of all the data points. And we can see some general trends here. Larceny accounts for a very large subset of the data, about 75,000 out of the 126,000 data points. So we can filter out all larceny data points, and we can see that we're left with considerably fewer points. You can start to see the yellow B's, which is robbery, the brown B's, which is burglary, the blue C's, which are assault offenses, and so on and so forth. Once you get to outside of the Washington, D.C. area, it's interesting to note that you see a lot of these red B's over in this area. These are motor vehicle thefts. It's somewhat interesting that it's not very common inside of Washington, D.C. Perhaps fewer drivers in that area, but interesting nonetheless. So we can continue to zoom in, and we've got the White House down here, and you can see that it looks like there was an assault offense right outside the White House. Perhaps someone got in a fight around there. Several burglaries, incidents of burglary, robbery. Of course, there's larceny all throughout the area. Several sex offenses in the area. I don't think Bill Clinton was in office during this time, so it's not sure what accounts for that. So you're able to filter on any of these categories in this area. For our data set, burglary, robbery, larceny, and assault are the most common incidents of crime. So this is the Washington, D.C. data set. It includes Washington, D.C. and a little ways west, going out toward the Reston area, and some even towards Leesburg and getting towards Purcellville and so forth. There are a few in Maryland, I believe, as well. So at the top of the web application, we have a button to switch to a Chicago data set. This was data that we collected from an RSS feed in Chicago over the course of the 1st of October through the 3rd of December. We gathered roughly 250 data points, and we used the DC dataset as training data to classify this data. You can see that the distribution of crimes is significantly different here. The vast majority of these are assault and burglary, with a few other things here and there. Some some things, these blue A's, the classifier was not able to identify, and they were labeled as other. So we can do the heat map view here as well to identify high areas of crime in Chicago. We can do the normal filtering, so we can filter out assault offenses and the other, and we can see where the majority of the robbery and so forth is. In addition to the Washington, D.C. and the Chicago data, we built a tool called Copable. For Copable, you can enter in a crime report. It'll pull your location information, and it will use the Bayesian classifier that we built to classify the crime. So in here we can say a man was shot in the buttocks, and we can hit classify and allow it to access our location. And this will take a little bit to run. This web server is running on a Raspberry Pi unit. It's relatively low clock frequency at 700 megahertz, and there's not a whole lot of memory and so forth. What we've done is, instead of retraining the classifier every single time we do this, we have serialized a trained classifier object, and this program right here deserializes this object and is solely running this description and testing it and spitting out what the Bayesian classifier says. So this takes about a minute to run. The training takes, we ran that on a machine with 8 cores and 16 gigabytes of memory, and that takes several minutes just to train the classifier. So that's why we've serialized that, to try to streamline this process. But given the hardware that this web server is running on, it's still a lengthy process. So you can see on the right here that this web application is pulling our date and time information. It's pulling our latitude and longitude. It's pulling our address, which is fairly accurate. We're in Torgerson Hall at the moment. And then when it's done classifying the crime that we've put in, it spits out the category here. And you can see that in this case, the crime description, man getting shot in the buttocks, was classified as an assault crime, which we find to be accurate. The DC data categorize these types of crimes as assault. There wasn't necessarily a shooting category. And we can do this for several other types of crimes, and we find this classifier to be fairly accurate. We can say a man stole another man's wallet, and we can wait and we can see what this will classify it as. Alright, so in this case we can see that the description, a man stole another man's wallet, was classified as a robbery, which we think is accurate. So we're hoping that this web application, or a derivative of it, could be used as an automatic classification tool. A police officer could perhaps use it on a handheld device. It would make classification and logging of these types of things simple, consistent, and we hope precise. For example, they could use some sort of text-to-speech tool to automatically classify their crimes as so. A man broke into my neighbor's house. Well, Siri's not perfect, but we're hoping that ultimately this could be a simple tool to use for police officers for automatically classifying their crime data for their own internal purposes. Alright, so we can see in this case that this was classified as burglary, which again we find accurate. So this is our crime classification and visualization tool by Kyle Morgan, Behrooz, Kamali, Jose, Cadena, and Devi, Mishra. Thank you for watching.